So in this video we'll have a quick rundown of how you will create graphs using Google Sheets for the three gas laws. And so the first one we'll start with is the first gas law experiment that we do, which is Boyle's law. And so with Boyle's law we're going to have our table which we've created in Google Sheets. Then you just highlight both columns. Now it's important to highlight them in the correct order, so we're going to have the volume on the left hand side, the pressure on the right hand side. Just drag and select them and then insert chart, and so we'll have insert chart, and for me it's going to default to a scatter chart because it's typically what I use in physics. For you that might not be the case, but what you'll have is on the right hand side you'll have a sub menu, the chart editor menu, which when you click down there you'll be able to pick the type of chart that you have. Now if you have your line chart, whatever is selected, that's fine, but you're going to go to you'll see a scatter chart that's there, and this is going to bring up this here. Now we're going to have to edit this in a couple of ways, and so I'll just get it a little bit bigger so we can see. The first thing I want to do, well, it's already picked up the label axes here, but it doesn't have a superscript as a 5, and so what I'm going to do just in this instance is I'm just going to put a little arrow pointing up. Now if we were doing this in an assignment or something, we would have to be a little bit more careful about how we were going to represent that, but as this is just a general teaching thing, we want it to be accurate, but it doesn't need to be perfect. And so just this little bar up here, it will be fine, and we can do the same for the centimeters cubed, like so. So our axis labels are fine. I'm not too fussed about my title. In fact, we can just get rid of that, make it nice and easy. Now on my x-axis, the x-axis starts at 1, and I don't want that. And you'll notice what I'm doing is I'm clicking on the element of the chart that I want to edit, and as I click on it, then it will open up a different menu. And so here I want to edit the numbers along here. I want this to start at 0, and so I'm going to here have my horizontal axis, and I'm going to have a minimum value, and I'm just going to set that minimum value to 0, and then I can press enter, and then this will change to here now, and that's looking pretty good. That's about as much as we can really do with it. I can add in a trend line, or you could add in a trend line if you wished. To do this, you would click on a point, so click on any one of the points and then say add trend line. Now it's going to do a linear trend line, which we don't want. It would be, I think, if we just try and find one that fits quite well, possibly there. So yeah, this looks pretty good. And that's really the graph that as detailed as we need to get it. The other thing that we can do is we can add in some better grid lines. Here it's just sort of auto scaled it, but we would like minor grid lines. That's fine. So the minor spacing count, and we're going to have 9 grid lines in there. So it's really important that you have 9 rather than 10. It seems counterintuitive, but if we have this going up to 0.5, then we need 10 divisions, and so what this is going to do is it's going to insert 9 minor divisions, plus you'll have your major division when it comes to here. So we'll have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10 going there. If you put 10 in here, it's a bizarre system, and I don't know why it's a feature at all, because you would then go up to 11 to get there, which is not what we want. So stick it as 9, We'll have minor grid lines. We'll do the same from the y-axis. We're going to have there, and that's looking a bit better now. We can much more accurately determine points and read from the graph to see what the points are actually saying. And so that would be the first graph that we have for Boyle's law. To make the second graph, we're obviously going to take this graph and as per the lesson, we're going to take the inverse of volume. So we're going to work out what 1 over volume is, and then we can replot the graph. So just for ease, I'm just going to push that over there. I'm going to get rid of that, but then I'm going to come here. So first thing I'm going to do, I'm going to get another volume column, and so just right click on the top there and then insert one left. And then I'm going to have 1 over volume. I'm going to open my brackets. And 1 over volume, I could do 1 over centimeters cubed, or I could just use centimeters and then my subscript to the -3, and that is exactly the same as just 1 over centimeters cubed. So there we go, I've got a label, I've got a unit, and now I'm just going to press equals and then type 1 divided by, and then click on the cell, press enter, and that's obviously going to give me 1, but you'll see up in here we've got the formula bar 1 over b2. Then you'll find this little square box. Now notice how the cursor changes. I've got the normal arrow here, which is just pointing to 1. If I move it over the line, I've got a little hand tool, so it means I can just drag this cell wherever I want. Or if I move there, then I get a plus. And what this is going to do, it's just going to populate the formula, not the numbers, all the way down the column. And so you'll see the little dotted line that appears there. I let go, and that will work out 1 over volume for me in those cases. Potentially, depending on how yours is set up, I know that this is probably edited a bit more than yours will be in the first place, but you will have to tell it the number of decimal points, which is going to be here. So you can increase the number of decimal points, or by pressing this you can decrease the number of decimal points. And so you want to make sure that it's in the same form as what you have here. From that point, we're going to select our first column, then we're going to hold down the control key and select the second column, and then follow the same process as before. Insert chart, and then now we have our second chart, and well, we've got our correct quantity and unit there. This one will need changed if I actually change it up here. No, it doesn't want to be smart, so I'm going to change it again here. So pressure times 10 to the 5 pascals. Check that the volume is on the bottom and the pressure is on the top. And then what we're going to do is, we can do a number of things here. First of all, I'm going to go to my x-axis. I want this starting at 0. And so again, minimum value of 0. We can just do that. Now we're going to have here, I'm going to get some more grid lines in. 9, remember 9 there. And I can click on the point. I can change the color, but what I really want to do, the SQA would like you to use a plus rather than anything else. We don't have a plus in here, so we can do some X's, and from that then all that's left to do is, if we click on the point, if I can find a point, that data point, right? So then we can just say trend line, add a trend line. And so what you can see here is that the trend line is just cutting just slightly below the y-axis. It would intersect around about here. Remember, this is real data that we have, and so it's not going to be perfect, and there will be some experimental uncertainty inherent in every experiment that we do. But in this case, that's fine. It's close enough. It shows a definite trend, and from this we will then be able to take our results of Boyle's law, which is obviously that pressure is directly proportional to the inverse of volume. Okay, well that's the Boyle's law graph. Moving on, we can look at the Gay-Lussac's law graph. Okay, for Gay-Lussac's law here we have our pressure, and how we measured it was pressure, and we got the data in kilopascals, so we can then convert that into times 10 to the power of 5 pascals here, and we have our temperature here. Same as before, highlight both columns, hold down, oh, sorry, there, oh dear. So we highlight both columns, we insert a chart, and then we'll get this. So this is not looking that great, and again our minimum value of 0. We can put in a trend line, which is going to go back there. Now I'm not going to do too much more to this because what we can see, well obviously we can't get a relationship from this, and so we've got to go to the next stage, which obviously from the lesson that we have is that we're gonna extend the axis back until we get an intersect, and so to do this we're going to extend our axis back. Now I'm gonna where are we? Horizontal axis. So I'm going to set the minimum value. I'm going to set this to minus 300. And what we can see here is that now we do get an intersection. I want to see that this is a bit. I'll try and get this a little bit bigger. And I'm going to play around with the axis values here. So I want to have our minor count, so we'll have minor grid lines in there. It's still a little bit too small to be able to accurately read that, and so I'm gonna have major step value rather than going in hundreds. If I go in, so I can go in 20s. Here we go. So this is looking a bit better. We can just change our minor grid line, add a minor grid line in there. And from this point then, I realise this is going to be quite difficult on your Chromebooks, but it is what we've got. What you can see there is that the intersection of that, if I can zoom in here. Can I zoom in more? I probably can. If I do it 400%. No, it's maxing out at 200%. It's not letting me do any more, but we're going up in twos, and so it'll be 1, 2, 3, 4, 5 boxes. That'll get me to minus 270, and look at that. 1.5 box would be minus 273, and so at the intersection, at the point where pressure and temperature become directly proportional to each other, it would be at minus, well, the intersect is minus 273 degrees Celsius, and then as per the lesson we draw the extra axis in which would be our Kelvin scale. what we can do with this is, again, we can just insert one column to the left, and we can have, if I just and just put temperature in Kelvin. And so to convert to Kelvin, we're going to just, again, equals, have this, and then add on 273. Highlight everything. We can then insert another, insert another chart with temperature in Kelvin and pressure, and then we'll look at the chart that this produces. Again, we're going to want to put that down to 0 this time. Add in a trend line, and there we go. We're having a perfectly directly proportional relationship. You would do the same, almost exactly the same as this for Charles' law. And so you can go and create these series of graphs on your own. There, perfectly happy with all of that. So hopefully that has been informative to you. Most of you will have been able to hack some of this together yourself and figure it out. But as ever, any questions, just ask, and hopefully most of it will have already been explained in the video lessons. But this was just a bit more in depth. And more of an in-depth way of showing you how to create the graphs in Google Sheets. Alright, thanks for watching. Bye now.